Okay, Mr. Giovanni. Number 4, the CSEC ADMAT June 2023 paper 2 solution. All right. This one gives us this function, which is a quadratic function. It tells us that the gradient is this. This is what we call a gradient function. And that it has a stationary value of 5. Stationary value is 5. All right. So remember, at the stationary value is where dy by dx equals 0. All right. It says determine value for a, b, and c. All right. So firstly, this is our dy by dx. So given this, they're telling us that dy by dx is this. So we have y equals ax squared plus, well, I'm just going to differentiate this, right? Because I don't have a lot of space. I'm just going to differentiate this. So from this expression, what dy by dx is equal to, differentiate the ax squared, let's zoom it up. I'm going to get 2ax, differentiate the bx, I'm going to get plus b, differentiate the c is 0. But they're telling us that this actually is equal to this, right? So let's set that up. So this is also dy by dx because this is a gradient function. And so I can put this thing equal that thing or equate it. So it is equivalent to 9 minus half x. So we compare the values. If we compare the values, we see that the b equals 9 as a constant. And we see that the negative half equals 2a. So we can make that conclusion in purple. So the b is equal to 9. We compare the values. We can put a therefore on this. We can say compare. The b is 9 right there because it's a constant. B equals 9. And the 2a is negative x, coefficient of x. 2a is not negative x, negative a half. Negative a half. So divided by this 2, we're going to get a equals negative a quarter. That's my value of a and b. But they did tell us that the stationary value is 5. So stationary point, this is equal to 0. So we can continue and say at the stationary point, at the stationary point, at the stationary point, the dy by dx is equal to 0. So this is equal to 0. And if that is so, wow, that small amount of space to do this thing. If that is so, then this is equal to 0. So let's shift this around, guys. So I'm going to write 9 minus half x equals 0. So x is going to be 18. Right? X has to be 18 because you want this to be 9. For this to be 0, x has to be 18. When x is 18 at the stationary point, the y value is 5. That becomes the stationary point. So stationary point, because we have the a and the b. Now we have the a and the b to substitute in this function. Right? And this is a stationary point. So basically giving us a point. 18, 5 is a point. But this is a stationary value. So basically, this is the value of y equals 5 when x equals 18. When x equals 18. So it means that the point 18, 5 is on the curve. 18, 5 is therefore on the curve. All right, is a point. Is a point. So we don't want that space to work with. All right, so I'm gonna put this in a box over here. Put this by itself over here. All right. So put the stationary, the gradient equals 0 to get that stationary, the value of x at that stationary point. But the point is now to find the c, we're gonna have to substitute. I mean, that's not necessarily the only way to do it, but to find the c, we're gonna substitute these values, the a, the B, the A, the B, and these coordinates into this equation, into the function. All right, so let's do that in blue. All right, so I want to plug the values in there. So I want to use the point 18.5 on the equation of the curve. So that 18.5 on the equation is going to give us the y value is 5, and the equation, the y value is 5 equals the A is a negative quarter. We're going to get negative a quarter times the x value squared, which is the 18 squared, times the 18 squared. And then we're adding the b, and the b is 9 times the x value is 18. And then we're going to plus the c, plus the c. This is the equation for us to find the c. Not thinking of another way to do it right now, guys. Not thinking of another way. My brain is saying there's another way, but I'm not thinking of it. So to find the c, I need to simply transpose these values over onto this side and subtract with the 5. So therefore, I'm just going to write it because I don't want a space. C is equal to, I want to take the 5, add this, and subtract that. Let's do it with the calculator. All right. This is ridiculous. All the space I represent do this work is so small. All right. So the C is going to be 5 first. And when this transpose over here is going to become a plus, so it's going to become plus. It's going to be 18 squared over 4, a fraction. 18 squared over 4. That's what this becomes, 18 squared over 4. And then this is going to be subtracted over there. So I'm going to now minus 9 times 18. I'm going to get negative 76. All right, negative 76. And so that is my answer right there. So can I write my answers? So C is that value. I'm going to just underline my answers. Wow, what like a space. So that's an answer right there. That's another one right here. That A value. And then this is my third value. Those are my answers. Answer, answer, and an answer. All right, then it says determine the nature of the stationary value. So to determine the nature, it's gonna be the A is negative enough, so it's gonna be a maximum, right? But the A is negative, but let's use the second derivative method. So we know that dy by dx is 9 minus half x. That's what we were told. And so d2y by dx squared is going to be this differentiate. It's going to get negative half, which is less than 0. Therefore, stationary value, the nature is a maximum. Something like that. All right, we could have said it from the value of the A as a quadratic function, and the A is negative. But I think the syllabus wants us to use second derivative to determine the nature of a function, right? Nature of the stationary points and a function. Nature of the stationary points. All right, next part. Next part says a drone is like a motion in a straight line. A drone tracks the movement of an object in motion on the ground. So a drone is tracking the motion of an object in motion and tracking the movement. It says the following movements are recorded. It moves at a constant speed of 4 meters per second for 5 seconds. That's the first thing. Its velocity increases uniformly for 3 seconds to 10 meters per second. It moves at a velocity of 7 meters per second. It moves at that velocity for 7 seconds. Well, for 7 seconds. Then it slows uniformly until it comes to rest after 4 seconds. It says sketch a graph of the movement of the object. Okay. So let's transferring this information onto this graph. Firstly, there's no scale, so I'm gonna have to scale it up. Let's just use 1 centimeter, 1 unit. All right, keep it simple. So this is gonna be 2, 1, 2. So it's gonna be 2, 4, 6, 8, 10, 12, 14, time in seconds. Up here, same thing. 2, 4, 6, 8, 10. No, it's supposed to be 8, 8, and then 10. 2, 4, 6, 8, 10. All right. Then I'm gonna make a sketch. Let's do it in blue. All right. Firstly, it has a constant velocity of 4 for 5 seconds. So start when the movement starts, it's a velocity of 4, which is right here, for a time of 5 seconds. Hold on, I don't know. Maybe my scale is too big. Maybe my horizontal scale is too much. What's the maximum time on this? Is 5, and then 3 here, and then 7, 15, and then 4, 19. Yeah, so this is too small. Can't reach 19. Can't reach 19. So maybe I have to go 5, 10, 15, 20, eh? Let's change it to that. 5, 10, 15, 25. I don't want that because I don't like those values. All right, 5, 10, 15, 20. Let's see what I can see. 5, 10, 15, 20. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Let's see what's that. 2, 4, 6, 8, 10. Easy. It's gonna be 4, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Let's get 12. All right. 2, 4, 6, 8, 10, 12, 14, 16. Good. Going up by 4. All right. All right. Is that good enough? That should be 2. So every line, that is 2. That is every line. We have 5 line. We have 2 divided by 5, which is same as 4 over 10. So each of these little lines will be 0.4. All right, so be careful with that one. Each of those little lines is 0.4. All right, let's put on the values though. So firstly, we're going to 5. 4 meters per second for 5 seconds. All right, 4 meters per second for 5 seconds. Let's just check this. This was 10, 15, 5 seconds. I was checking if the scale makes sense. All right, let's bear with me. We go for 3 more seconds to be 8. Then end up at 15. Then 4 more seconds. And 7 more. Yeah, 7, then 4 more seconds. All right, go circle it. Is that? Let's just circle up here. All right. So 4 meters per second for 5 seconds. So where is 5 seconds? So let me draw this part in blue. So we have 4 meters per second for 5 seconds. All right, so let's put this in right here. 5 seconds is going to be exactly halfway between the 4 and the 6. So I'm coming right here. Right halfway between the 4 and the 5. That's 5 seconds to there. All right. This part said it increases speed for 3 seconds to 10 meters per second. So for 3 seconds. So 3 seconds from 5. This is 5. It means that you're reaching 8 seconds. All right. 5138. All right. 5138. You're reaching 8 seconds and you're reaching a speed of what? 10 meters per second. So 8, 10. So you're coming to here. The straight line is coming to there. Let's point up here. So we just need to draw a straight line there. Go so straight. Let's work with that one. That's the second phase. And then it moved at that velocity for 7 seconds. So what time are we? We are at 8, 8 and 7, 15. So this is 12. Right here is 14. Right here is 14. Let's make sure we get the scale, get the values, these places right. Right here is 14. The 15 is right between the 14 and the 16. That's 15 is here. So it basically maintain that velocity until it came 15 in between here. So zoom up, we're going right in between these two lines. Right there. All right. That takes us down to the 15. Good. So that's where it went next. All right. And it says now, it then slows uniformly and come to rest after another 4 seconds. So where are we? We're at 15. I have to go down to 19, right? Because 15 and 4 make 19. So this, let's finish the scale. Let's write this properly. So this is 12, 14, 16, this should be 18, this should be 20. So 4 more seconds from here. 4 more seconds, yes. So right now we're at 15. 4 more seconds going to take us to 19. Right there. So we're coming to rest at this point. All right, coming to rest at that point. So a straight line down here now. We basically finish it. Bam. Bam. Good. Use a roll and draw it. Don't draw it friendly like me. That's my sketch. That's my graph. All right, that is my graph. That's my graph. I mean, could have used a different scale, but it don't really matter. Don't really matter. That's my graph. That's what I want us to do. Must do something with it. It says, calculate the distance traveled by the object in the second stage. Distance is equal to area under the graph. Distance equals area under the graph. Distance under the last time graph is area. So the distance traveled is going to calculate with the area. Where is that? In the second stage, or the second part of the journey. Second part of the journey is right here. So they want us to tell them the area under this part of the graph. Right? Which is a trapezium. Because it has a parallel side and a parallel side there. And the distance between the parallel sides is 3. So basically, I'm going to sketch trapezium that we have. So like we have this trapezium like this. So a sketch of it. The dimensions on this trapezium would be, firstly, here on the right side is 10. So this is 10. And then this short side is 4. Those are the parallel sides. And then this distance between them is between 5 and 8. So the distance between them is 3. So on the area of that thing. To get it, right? Area of that thing. I'm shading it now. Shade it in purple or in green, pink, in purple, yes. So I'm trying to find that area that gives you distance traveled. All right, so I'm gonna copy this down as the dimension that I have to use. Copy it down here, paste it over here. These are the dimensions to give me my distance traveled. All right, here on the graph. So So I need to calculate this area and put it here. So this area relates to this area. I'm gonna say area inside here. Area. That's what I want. Area. So that gives my distance. So distance, the second stage, second part equals the area there, right? So this is the area. Half the sum of the parallel sides, the 410 are the parallel sides. 14, Mr. Shaw, let's write the 410. Show the work. And this time between the parallel sides is 3. All right. So half of this 14 is 773 is 21, so within 21 meters. The distance traveled in the second phase, 21 meters. Right. What is that? Let's just check it was 4 and 10 for real. Yes. All right. Next part now says determine the object's acceleration in the final part of the journey. In the final part of the journey, it's actually decelerating, but because I asked for acceleration, you have to put the negative on it. You have to put the negative on it. If the question was to find the deceleration, you would not put the negative on it. But acceleration on a speed time graph, on a velocity time graph equals gradient. Gradient. All right, gives the acceleration. So the acceleration, I first need to look for the rise and the run. Acceleration equal. The rise is going to be negative because it is coming down. What is the negative rise? Coming down from 10, right? So this is the rise coming down from 10. That's negative 10. Negative 10 over the run. It's the time it takes to rise. For that. The run is from 15 to 19. That's 4 seconds. 4 seconds. So divide that by 4 seconds. That gives the acceleration. That's 10 over 4. And it's negative. And divided by 4. That's 2.5, right? Negative 2.5 meters. It's meters and seconds, right? Let's make sure. Seconds and meters per second, right? So it's meters per second squared. S to the minus 2. I have to put the negative on it. If the question asks you for the deceleration in the final stage, then you could leave off the negative because deceleration already means that the speed is falling. So it's going to be the rate of decrease of the speed. And we are done with another question. Lovely. Lovely. So I'm trying to stay awake, guys. So let me pause here and I start number 5 right here in the next question, in the next video. All right. Number 5 in the next video. Let's do that. See you.